Okay, so the next thing is we introduce the intersection and union of sets. So here we have a set A and a set B, and this region in here is called the intersection of the two sets. So what do we mean by the intersection? If A and B are sets, then the set of all the elements that belong to both A and B is called the intersection of A and B, and it's denoted A intersect B. Okay, so this is the notation. So if we have a set A and another set B and another set C, we can ask to find the intersection of A and B, of A and C, and B and C. So it's the intersection of A and B. So they both have a B, they both have a D, they both have an E. So I think it's, what is it, B, D, E. Okay? Yeah, B, D, and E. Therefore, by the way, this kind of picture is called a Venn diagram, and it was named after this person. Okay, so that's called a Venn diagram. Okay, so anyway, it's the intersection is BDE. What about the intersection of A and C? A and C only have the element A in common, so the intersection is A. A intersects C, and B intersects C. B and C have nothing in common, so we write that the intersection is the empty set. If two sets have nothing in common, like B and C, they're called disjoint sets. So A and B are disjoint if they have nothing in common. It means that their intersection is the empty set. So, for example, in the example up here, A intersect B, the intersection is not empty, so these are not disjoint. On the other hand, C and D are disjoint. Now, what if we have three sets like this? What do we mean by the intersection of three sets? It's the set of items which are common to all three sets. The intersection of any collection of sets is the set of elements that belong to every set in the collection. Okay, so here we have A, B, C, D. We can ask what's the intersection of A, B, C, D here, and it turns out to be 2 and 7 are the only two elements that are common to both. I'm sorry, common to all four. Okay, you can read this example. Let's go on to union. So what do we mean by this symbol? What do we mean by the union of two sets? So we mean, I think they have a picture here. So if A and B are sets like this, the union is everything in here. Okay, so the union is what? If A and B are sets, then the set of all elements that belong to A or B is called the union of A and B, and it's denoted by this. And they give a little warning here. The word or, which they use here, is used in the inclusive sense, so that the statement P or Q is true when at least one of those statements is true. In other words, P or Q is true in the following three cases. P is true and Q is not. Q is true and P is not. Both P and Q are true. So in other words, when they say if it's in A or B, they mean if it's in A or in B or in both A and B. So both A and B is also okay. Okay, so here's A and B. What's the union of these two? So A is in there, B is in there, C is in there, D is in there, E is in there. A, B, C, D, E. And then B is in there, of course, we already said that. D is in there. E is in there, we already said that. But G is also in there. Let A be any set. Find A union the empty set. So what's the union of A with the empty set? It's A. Okay, and we can also talk about a collection of sets and their union. is the set of elements that belong to one or more of the sets in the collection. So for example, the union of A, B, and C is all of these. Here's A, B, C, D. What's the union of these? So any element that's in any of these will be in the union. Okay. Okay, let's go on. What's this? Find. Oh, okay. So let's try this. Suppose we want to find C intersect A union B. C intersect A union B. So first we'll find A union B. So where is A union B? It's here. And then we want the part of that which intersects with C. So it's this part. So this is C intersect A union B. Okay, and you can look at this one. That one as well. So actually look at this. This is C intersect A union C intersect B, and that's because C intersect A is here, right? C intersect A is here, and C intersect B is here. And so the union of this and this is this. So the union of C intersect A and C intersect B is this. But look at that. It's the same as the answer we got just before here. This is a different expression. Okay, this is a little bit small, but this is C intersect A union B, and this is C intersect A union C intersect B. We get the same region, right? So that suggests that this expression is equal to this expression. Okay, so that's kind of interesting. So they write that down. C intersect A union B is equal to C intersect A union C intersect B. And this is kind of similar to something we do in regular algebra, where we say C times A plus B. That is, C times A plus B equals what? C times A plus C times B. So if you change this symbol to multiplication and this symbol to addition, you get a familiar algebraic expression. That's algebra when you're using numbers, but these are not numbers, these are sets, so we can talk about this as a kind of algebra with sets. Because this means it's true for any sets that we choose. It doesn't matter what C is, doesn't matter what A is, doesn't matter what B is. This statement will always be equal to this. Just like we say that A times, when we do regular algebra, A times B plus C is always equal to A times B plus A times C. When I say always equal to, I mean no matter what numbers you put in there, it will be true. Here it's true no matter what sets you put here. And that previous one was called the first distributive law for sets. And here's another one which you can prove yourself using these kinds of diagrams very easily. That's called the second distributive law. It says C union A intersect B is equal to C union A intersect C union B. Okay, let's very quickly look at this. In an experiment with hybrid corn, the corn plants were classified into sets as follows. Q is quick growing, R is rust resistant, Y is all yellow kernels, and W is all white kernels. Describe the characteristics of the plants in the following sets. Q intersect Y. So that's the set of corn plants that are both quick growing and that are in Q and in R. So that means they're both quick growing and rust resistant. Okay, the plants that are quick growing and rust resistant. How about R union W? That's the set that are rust resistant or have all white kernels. So the plants that are quick growing, white, B, oh sorry, what happened? Oh well, I did something wrong. Q intersect Y in both Q and Y consists of quick growing and yellow kerneled. This one is what? Rust resistant or white kerneled. Okay, what about this one? It's kind of complicated. This is rust resistant and quick growing, or rust resistant and yellow. So this one might be able to be re-expressed in a simpler way. Do they do that? Because of the distributive law. Yeah. Yeah, no, they don't do it, but you could do it. You could rewrite this using the distributive law, and maybe the expression in words would be simpler than this. Okay, so you can read the rest of these.